Hello, I'm Luis Gonzalez. I'm going to show you how to use ManLite, which is my 2D engine. The first thing you will have to know is what each panel does. If we go to the left, we can see that we have the scene hierarchy, which it will store and it will show what game objects do you have in the scene. For example, you have the main camera, which is a default when you create an empty scene. You can right click to create empty game objects and you will see that it will store here. It is a tree-like structure in terms of that you can create game objects and set it as childs of any game object. Okay, the next panel I'm going to show you is the project panel. Here you will have your files. It is synchronized with your folder assets. If you create here a new folder, it will create here. If you rename it, it will be renamed here. If you delete it, it will disappear. Okay. You can also drag and drop things. You will duplicate, set it inside, move it outside. It is very manageable. You can also drag things to everywhere. If I had a scene, let's save this one, you can drag to load it, or even double click to load it. The next panel I'm going to show you is the console. This will show you what is happening in the engine. For example, the new scene has been created, the scene has been saved, new game object has been created, etc. You will also have useful information when we compile the scripts. Now we have no scripts. Now the next panel I'm going to show you is the animation panel. First you will have to load a sprite and an animation. Let's go to file, let's load a sprite. Since I'm going to load a samurai. Since we don't have an animation, let's create one. So let's add a frame. Let's set it 32 by 32. Maybe it's okay. 96 by 96. Now we can duplicate the frame. And we see here in real time what will be the result of the animation, and in this we will see what we are editing. Let's duplicate the frame, and once we have all the frames done, you can change the speed, you can unselect the loop, you can make it ping pong, and even flip them horizontal or vertical. Now we have it here, let's save it. Let's call it Samurai Idle Animation. And now we can clear the panel. And let's see how to implement this animation. First, let's don't show the colliders. And let's create an sprite. You will select the idle image. Now that you have an sprite, you can implement an animation. In order to implement an animation, first you must have an sprite, as it says here. The animator will manage all the animations. You can add more than one animation, create new or add animation. We will select the idle animation. Let's activate the pixel art. And we will see the animation here. If you want to edit it, you can click here on edit and change the speed. It is important to save it again, because it is an external file. If you close it, it will not be saved. You must save every change you do to the animation. Okay. This is the automatic save. It will save the scene automatically. It's 5 minutes of inactivity. If you don't load, if you don't save, it's 5 minutes. Every 5 minutes it will save the scene. Okay, now that you see how to use an animation, let's go back. Let's see how we can manage the sprite. Do you remember that you can flip horizontal and vertical? It will be applied here. But we can also do that from the sprite. The sprite has some options. Let's remove the animator. We can change the image. Right now we don't have any other image, but we can also drag and drop any image to here, which I won't do because it's already loaded. Okay, first of all, the first option you will have is the pixel art. You will see the difference, basically. If the image you're using is pixel art, you must activate this option in order to see it better. If it is not, you shouldn't. Then you can change the section of the image. Basically similar to the animation. You can also flip horizontal and vertical, similar to the animation, and you can also create an offset. For example, if the main point is here, you want to make it in the foot, you can change the offset of the image. Perfect. Now let's go to see how the camera works. Let's activate the colliders, and you will see 3 main options: the camera zoom and the viewport size. Here maybe it's not really representative of what would be this look like, but if you change to game and set the camera, you will see how this is being modified. You can also click on colliders in order to don't see the camera gizmo. Okay, next thing we're going to see is the audio source. Let's create an empty object, or let's call it audio. We can set to the audio source by adding music or adding sound, or we can drag and drop. We can hit play to hear how this will sound like. We can change the volume. We can set it to play on awake in order to make it sound from the start of the scene, or play loop, so when it ends it will sound again. Perfect. Let's save the scene, Ctrl S, and let's play it. The next thing I'm going to show you is how the spatial sound works. If you enable it and you set the max the maximum distance, it will be calculated by the amount of meters, which one size of the grid is 1 meter. Let's put 10, which is the default, and the listener will be always default. It will be the main camera of the scene, but you can change it by dragging an object to the listener. So if we hit play, the listener, which is the player, will hear in a special way the sound effect. It also works in the y-axis. In terms of music, we could and change the volume. Again, we have the same options. If it is loop, if it is play on awake, and its volume. The music cannot be spatial audio. Okay, the next thing I'm going to show you is the collider. In order to show you, we'll create a new scene. And let's create a collider. This will be the ground. Let's make it, if it's a ground, it should not be dynamic, it should be static. So let's uncheck this. You can change the color of your collider. You can change the shape, if it's a circle or if it's a rectangle. You can also lock the rotation. You can also set if it's the sensor. If it's sensor, the physics body, any other collider won't collide with it, but will trigger that it has been collided. Then we have the mass, but since it's static, it doesn't really matter. The linear damping. The linear damping basically is the friction with the air. If we move this up, this will be more like if we are in the water, for example, that the air is very dense, let's say, and is it set to 0? It's like the friction but in the air. Then the friction would be the friction but in the ground when you touch any other object. If we change this, it will affect any other object that is moving on top of it. Then we have the restitution, that it is basically the bounce. If we set it to 1, it will return to the same. When it drops, it will return to the same height it began. If it's more, it will bounce even more and more. If it's less, it will bounce less and less. Let's set it, for example, to 1. And then we have the option if the game object, if the collider will use gravity. In this case, doesn't really matter because it's static, but we can activate it or deactivate it, and we can change the gravity scale. It's how many times this vector, the world gravity, will affect the game object. But we're not using it and it's static, so then we have the world gravity. It is here, but it is applied to every object in the world. If we change it here, for example -45, and create another game object, we will see that it's the same gravity. You can set it to default because it affects all the game objects, all the colliders in the world. Now that we have this is dynamic, it's not sensor, it uses gravity, normal gravity. Let's put it here and it will have to bounce and come back to the same height, as you can see. We can change the bounce effect, and you see. Let's not make it bounce. By the way, when you do something to the scene while it's playing, or maybe stop, when it is stopped, you can change this. But when it's playing, every change you do won't affect the original scene. If we now stop the scene, it will return all to the previous state, the restitution won't be changed, etc. We can also lock rotation. For example, if we are playing and we move this, it will change the angle. So it basically works as intended. We can now rotate the ground, make it larger, and now let's see how this affects. So it's basically a collider system. It's very simple and easy to use. The next thing I'm going to show you is the canvas. You can set the canvas to two things. You can set the canvas to any game object, for example here, and it will work as you can set these 5 options, these 5 UI elements. An image is basically an image. There is nothing with it. You can change his internal transform. So instead of this, we can also set a text. Let's change the alignment. Let's put it centered. Let's make it smaller. And now when the samurai moves, this will move. But this changes if the canvas it is set to a camera. For example, if we set the canvas here, for example text again, let's change the font. And we change the parameters of the camera. Let's play. So it won't be, so we can reverse it later. It will change with the camera. So this we can see that this is being deformed. But if we're seeing the game view, we can see that it is static. And what changes is the everything other. As I said, there is a lot of UI elements. We can also have the button. We can set the idle state 6 set it to idle. You can see a current value. For example, this will be, we can give it an offset. And this would be a slider. For example, if false state, let's give it the same, but changed. So it would be modified like this. You can also change the design and the alignment, for example. And you can also change the design. This design, which does is to change the first and the last, and it will be different. They will be different, basically. And you have a lot of more options. It's just play with it and see how the result is. Okay. The next thing I'm going to show you is basically the particle system, which I think it's the funnier part of the engine. You will see a gizmo similar to the camera to see where the particles spawn. And let's add an emitter. The particle system can have a lot of emitters, as you see. Okay, the default is this. So let's go by the options. The first option I'm going to show you is if the transform is locked or it is not. So if we change this, you will see that it is locked. The particles, even if they are already spawned, will move along with the transform of the game object. But if we unselect this, you will see that it will do only that on the particles that are going to spawn. The already spawned will ignore the transform of the game object. If we set a lot of more particles, it will be easier to see. Perfect. With this kind of particle system, we can create a lot of things. The first thing is it is constant of each burst. For example, let's create a lot and it will burst one time. Then we have the option of burst constant. Okay. We can change, for example, in the spawn options. We can also change the lifetime. Almost every single value in the particle system works with a randomizer. When you can change, you can set a randomizer from the number 0.5 to 2, basically. So when we spawn particles, some will last less and some will last more within this range. Next thing we can do is basically the first color. We can, for example, set it to black, white. It is really useful, for example, let's start it black, change the alpha to orange, and here we have the result. Then we have the initial position. For example, it will be in base of this. If this is 1 meter, if we want to be spawning in this range, and the pivot is here, so let's put -1, -1, 1, and 1, and it will be spawning in this range. The next thing we can do is the same for everything. The initial direction, I don't want it to move. The initial direction is 0, it will be static. We can also give it a direction to the left, a little bit to the left, other ones a little bit to the left and another ones to the right. I want every single one to move up. Everyone will go up and then down. Everything will go down. Then we can change the speed. This is the direction, but the speed is managed by this. If it is set to 0, you won't move. You can change it and put extreme numbers. Again, it's a range, you can play with it. The initial angle, for example, I want it to be inclined, it will be a random number. You can also set the angular speed. And also the initial scale. And this will be the initial settings. Then we have the final settings. I want the final speed to be 0.1. So they will start not moving, and at the end of the lifetime they will start moving. I don't want to use it. Now they have the final color. I want them to disappear. They were black, now I want them to disappear. We can also set a random position, a final position, which all the particles will die in the same position or range of position. Then we have the final direction, which now they're not moving, so you won't see. The final angular speed they will set to 0, so they will be stopping by itself, as you can see. Now we can also set the final scale and the wind effect. The wind effect, they will make it, as you can see. I think if they have no direction, it don't work. The speed. If we set the initial direction to in X position, it won't move. Going up in a straight line. The wind effect, if you can see, the initial direction, it's saying that it should go up, but it is not going up. This is because of the wind effect. If we unselect it, it's everything going up. If we can change, we can play with the values basically. As you can see, you can also make it affect only in the X axis. It's going to right to the left because of the wind. And finally we can change the render type. As you can see, now we're seeing squares, but you can also change it to a circle. You can change it to an image. The default image is the placeholder, so you can change the text too. And you can also set to pixel art. And you can also set to font. So the particle system is really fun to play with. I will show you some more examples of things I did with it. One is they're mostly in my prototypes. Okay, let's delete this. Let's create a new sim. And now we have the tile map. The tile map is incredible. You can choose, for example, this tile set, and you will see nothing. You can edit the tile map. This is what will be shown. Oh, it's really small, isn't it? Let's change the grid dimensions, for example. And we have three paint modes. The selection, you will select this, select the range, and you can paint the range with any tile. You don't want to see numbers, you can hide the numbers, or maybe go to the scene and see how it is going. There is also another paint mode, for example the bucket, that you will select a tile and then you will paint everything. And finally we have the brush that you can select, arrange here in the left in the tile set, and you can paint here. You can right click to erase. You can also erase in bucket mode or in selection. With the right click, it's the erase. Okay, the next thing we can do with the tile map is basically import from Tileable. If we have, for example, a tiled file and it must follow some requisites, for example, the tile set must be embed. I think it is this button. If it is not embed, it won't work. It must be embed. It cannot be an external .tsx file. And we can import it. If we export it as JSON file, we can import it. If we go here to the tile map and we see the JSON file, we can drag in and you will see how it is imported. It will be automatically set by layers, and it will be automatically set to a layer. And we can also not only import it, but to edit it. You want to add more clouds, you can. And see how it affects here. There is more clouds now. You can also import it by going to File, Import here. Now, the next thing we can do, let's create a new scene, is let's leave the script for the last. It's to create a light. When you create a light, it will all turn off. We can, for the book, in order to see everything in the scene, and check this and see what's happening in the scene without any light. You can basically have three types of lights. The area light, which can only be one in the scene, it's here. There can only be one area light in the scene, which you can change the intensity, you can change with the colors, however you like. Let's put it black, white, change intensity, whatever you want. We can have point lights. We can change the radius, we can play with intensity again, they change the color, the same. And also we can have the spotlight. Basically you can play with the range, with the parameters, and you can play with it. You change the color again, it's exactly the same. And then we have the scripts. You can basically, if you don't have any script, for example, now I don't have any script, we can create a script. We can give it any name, for example, script 1. And if we go to scripts file, we'll have it here. We'll see that the script is already loaded for us. We can just add things. We can also create public variables. If we save it and go here, it will load again the scripts. It will log wherever it has to log, but now it compiled successfully. And if we implement the script at the script, the one that created right now, we can see that we can modify the integer that created here. We can also play with public, for example, string string equal to test. You can also create public game object test game object, and we load. We'll see here the test that was here, blah blah blah. We can change it. It will not be changed here, it will be changed internally. The game object, in order to reference a game object in a script, as you can see here, in order to use this game object, you can create an empty, for example, and drag it here, for example. It will set the ID and the name, and this will manage it internally. If you want, for example, to change the tag here on the start, we can do test game object tag will be, for example, test. And right now we can see that the tag here is default. If we hit play, it will be changed to test. If we stop, it will return again to default. Now, what if we want to access the game object that is containing the script? For example, I want to access empty game object, which is the one containing the script, from here. We'll just have to do the same. Change here this by attached game object. Let's set it to test. Let's see that this is default. It compiled the scripts. It is default. We hit play, it will be changed to test. It is game object, the one containing the script, will be changed to test. We can do very much things with this. You have the list of every script in the web page of the documentation of ManLite. But you can also access, for example, I want to access the transform. Let's change the transform. We can hit here, provide transform my transform. Here we will set the my transform will be a new transform of attached game object. Here we can also play with the inputs. If we hit if input get keyboard key, I don't know, I think I want to get for example the A button. Only if the key state is down. So if this happens, I want the transform to set world position to, let's first create the back 2D. Let's create the position, which will be new, back to F. And for example, let's set it to 0, 0. And this will be position. So when we hit A button down, we will move the game object, the touch game object, to the position 0, 0. It compiled, it changed. Whoops, misspelling. Now it loaded successfully. So if we move here, for example here, we'll see here the transform. When we hit play, it will move, but if I hit the A button, it will change to 0, 0. And this with the list of all the scripts functions that we can use, there is a really extensive world of things that we can do. I think there is not really much things that I can show you. Maybe I can just show you examples of the scenes I can do with this engine. For example, the Dark Forest I talked about. As you can see, the fire camp, it's loaded to the player. The player is the one that has a collider, then has the movement, etc. It also has the game object samurai animation attached to it, which is a sprite, in order to manage the sprites, the animations in the script. You can see that we're using several lights, the spotlight in terms of making it look like the moonlight, the particle, the fire cam lights, the tree lights. As you can see, if I hit play, you can see, you will hear the sound, but you can also see how we can play with the particles. Here we have small red making seems like it's fire. We can also have the smoke here, and we have, for example, the particles make look like a fireflies. And we can also, we have another one here to concentrate them. Here they're more dispersed. And with the script we can move. From the scripts we can trigger the sound. You hear when I move, there are footsteps. When we're close to the fire, we will hear the fire. And again, with this engine you can do pretty much everything. You have a lot of examples. For example, you have test scenes. Then you have also a punk game I made. And it has also particles, as you can see. You have also inputs, and the scripts will be moved. This is all as particles everywhere. It's basically that. I also think I didn't talk about is the prefab. For example, let's create a new scene, and here I have a set of prefabs already created. For example, let's take the prefab, the samurai prefab. The samurai prefab basically has its collider, it has its player script in order to move, it has a light, which is an area light. It has an animator for its idle animation. It has a transform, it has its sprite, etc. It's a prefab basically. You can revert to prefab here. You can also create another, let's create an empty scene. Then you have, for example, the yellow orb, similar to Geometry Dash. And you will see here how it works. It's basically similar to the Geometry Dash orb, with its particles, its sprite, even if it's collider. And then we have something that I use, that's for example the Isaac tier. Yeah, it has this position. If I hit play, it has basically a script that will make it auto-destroy in 1 second. And this will, you can see this basically in the scene of roguelike, which is a prototype. That will die if that amount of seconds passes, or if it collides, for example, a wall, collides the fly of the door. If you go to the door, it will be the pit. You can take this item in order to shoot faster. You can heal. You can see your life here. So you can basically do a lot of things. For example, you can see the sprite. The animation has a lot of. The sprite has a lot of animations. The body the same. And if you could see the scripts, you will see there you can do almost everything. For example, basic movement. You can set the variables here. You initialize them. You play with it basically. So this is my engine. I don't think there is something really missing. Well, you can search here, for example, map colliders or whatever, and it will work. I don't think I'm missing anything. Well, the shortcuts there in the documentation, but they're easy. You can move the camera, for example, by middle button dragging. You can zoom out with the middle button scroll. You can also right click and use WASD to move. You can hold shift to move faster, hit control to move slower, etc. Remember that this project is open source. If you really want to collaborate or use it, etc., you're free to do so. You can, if you have any doubt of anything or recommendation, you can also contact me. Put a comment below in the commentary section. And well, this will be the tutorial on how to basically use ManLite.